Welcome, Algebra 2. Let's take a look at Chapter 6, Section 5, using properties of logarithms to evaluate logs, using our properties to expand or condense logarithmic expressions, and we will get to using the change of base formula to help evaluate logs. To start off, you and your group are going to have a little activity. It is a matching exercise, and I want to demonstrate exactly what I mean so you have an idea. There are various boxes. In each box, you're going to match. For instance, x to the third times x squared. Well, which one of these it is? I would really appreciate it if you simply draw a line to the correct one. It makes it so much easier than trying to match up the letters. Okay? Each answer here matches one problem. You will not use it twice. Then you'll slide over here, taking a look at these and seeing log base 2 of 2 equals which of these? Well, if you think back to your loop method, 2 to some power is 2. 2 to some power is 32. 3 to some power is 9. Should make it pretty easy for you to figure out which one's which. What you're trying to do is you're developing the rules for logarithms. I'm not teaching them to you. You're figuring them out as we go. You're supposed to somehow figure out this to match it with one of these. If you're stuck, my advice would be maybe you start with something like number 2, because there's only 2 answers that have log base 3. It's got to be one of these. See if you can figure out which one it would be. If you figure that out, you'll probably figure out the pattern. And once you do, once you think you know what the rule is, log base b of x plus log base b of y equals log base b of what? What do you do with that x and that y? So, adding two logarithms, what's the rule? That's what it's trying to say. The opposite of adding logarithms would be subtracting them. So, if you figured out what adding means, subtracting is going to be the inverse. Be simple. Again, if you're stuck, maybe you start this time with 1 or 5 because there's only 2 answers that have log base 2. You could probably figure out which one's which. Then, figure out what the rule is. When you subtract 2 logs, what do you do with that x and that y? Now we're down here. Oh my goodness, that looks really, really confusing. It's one of these. Figure it out. If you can't tell, look closely at the numbers and see which one it is to try and figure out the pattern. Once you've got those 3 rules down, you'll be able to slide over to these 2 problems and solve it. When I say solve, you'll try to write it using those rules for logarithms. Then maybe you use your loop method to actually come up with an answer. Your answer should be a single number when you're done. A little tougher down at the bottom. Write as a single logarithm. This has 2 logarithms. You're going to use the word log base 3 one time. Figure out what you do with your x and your y. You've got 1, 2, 3 logarithms to base 2. Well, by the time you're done, you will only write the word log base 2 one time. That's what a single logarithm is. You've got 2 different logs here. Figure out what this number, where it's supposed to go. Figure out where that number is supposed to go. Figure out what minus is. Put it together as a single logarithm. Take about 15 minutes to do that, and then come on back with your group. All right, it is time for notes. Welcome back. Chapter 6, Section 5, Properties of Logarithms. We'll start with an example here. Log of 5 plus log of 8. We could put it into our calculators. On your calculator, grab that. Log button is over to the left. Press log 5, close your parenthesis. Gotta close your parenthesis. Plus log 8, close your parenthesis. I got about 1.6021. We take, excuse me, we'll take logarithms out to about 3, maybe 4 decimal places and round. I left a little space there for a reason. That logarithm can be rewritten another way. If you gathered from that group activity, there are 3 rules for logarithms. The first rule is when you add 2 logs, you multiply the numbers. So when I'm adding 2 logarithms, I could rewrite this as log of 5 times 8, which is log of 40. Try log of 40 on your calculator. You'll see it is also equal to about 1.6021. The second rule that you should have seen dealt with subtraction. Subtraction in log world is the opposite of multiplication and the opposite of, I just said that backwards. The opposite of addition is subtraction. The opposite of multiplication is division. In log world, when you subtract 2 logs, you divide the numbers. So we keep our log base 2. Remember, the base should be tiny and down in the basement. And then we're going to go 18 divided by 6. Minus means divide. Well, what is 18 divided by 6? It's 3. There's our exact answer. Not a very helpful answer. So what we can use is called the change of base formula. A change of base formula lets us evaluate on a calculator something that is not base 10. Like base 2. Our calculator can only do it when it's base 10. If we press log of 3, that's not the right answer. This is log of 3 base 2. It means 2 to some power is equal to 3. What? 2 to some power is equal to 3. How do we figure it out on our calculator? We do log of 3. You'll get parentheses. You'll close them. And then you divide by log of the base 2. Log 3, close parentheses, divide log 2. I got about 1.58496. I'll just call that a 5. That means 2 to this power is equal to 3. 2 exponent 1.585 gets me to 3.00000777979. Really close. Why is it not exact? Because I rounded. That's why. Your calculator only uses base 10 because our fingers use base 10. When we have different bases, you have to apply the change of base formula. Time for a little logarithm. Anybody up for a little dancing? No? No? Really? Okay. Our third rule that you saw in your group work was that when you have a number out front, that number out front is an exponent. Our exponents are out front. So to rewrite this, we could say log base 7 of 12, putting my exponent back, squared. Well, how much is 12 squared? 12 squared on your calculator, 144. There's our exact answer. 7 to some power is 144. Let's put it in change of base formula. Log 144, close parentheses, divided by log of 7, I got about 2.5539. So I'll call that about 2.554. 3 to 4 decimal places, that's what you're aiming to do. What does it mean? It means 7 to this exponent gets me 144. Well, it'll get us close to it because we're rounding. All right, you try, rewrite it. See if this is using your rule for addition, subtraction, or if there's a number out front that is an exponent. Hit pause, try to rewrite it. All right, welcome back. 2 is out front. That makes this an exponent. I could rewrite this as log base 5 of x squared. Can't really use a calculator on it. All right, you try. Hit pause, rewrite it. Welcome back. 3 is out front. That's an exponent. So this would be log base 5 of y cubed. When you have a number out front, that is an exponent. Or if you have an exponent, you can always put the number out front. And what that really does is it's 2 times the log of x base 5. It's 3 times the log of y base 5. And oddly enough, it turns out to be the same thing as the log of x squared to base 5. The log of y cubed to base 5. So putting it together, writing it as a single logarithm. We have the word log twice. We're going to use the word log once. That's what it means by single, right? 1. Your first step would be putting your exponents back. Well, we did that up here and up here. So, exponents are back. Your next step is to look and see, do you have addition or subtraction? We have addition. Addition tells us that we're going to multiply. What are we going to multiply? We're going to multiply x squared times y cubed. So, x squared times y cubed. That's our answer as a single logarithm. I just can't talk today. People have 10 fingers and 10 toes. It makes sense to use base 10, says logarithm. Natural law says naturally. Get it? Because natural log is just log base e. That's what ln is. Natural log is log base e. Base e is used that often that it has its own special button on the calculator. Log base 10 comes strutting down the path, and pi says, she's hot. E says, yeah, but she's not natural. Get it? Not a natural log? Right, as a single logarithm, we have 3 rules. We have plus means times, minus is divide, and exponents are in the front. Do you see any number out front here in front of the log? Then this doesn't have an exponent. Is there a number in front of this log? Then it doesn't have an exponent. Instead, let's see our other 2 rules. Addition is multiplication. Subtraction is division. I see subtraction. As a single log, we'll take this here and we'll divide it by this here. 16x divided by 2x. Hey, we can do a little simplifying here. 16 divided by 2 is 8, and x divided by x cancels out. So this is log base 4 of 8. Could you get an answer on a calculator? Remember, it's not base 10. You can't just do log of 8. You have to use your change of base formula. Log of 8, close your parentheses. Log of 8 divided by log of 4. I got 1.5. Here's what it means. 4 to the 1.5 power is 8. 4 to the 1.5 power is 8. You don't believe it? Check it out. 4 exponent 1.5. Boom! 8. Told you. Didn't lie. You and your group are going to do a little properties of exponents in Desmos. If you're going to work with a partner, put both your names in when you're done with that. There is a group work practice paper in Desmos. You should be spending maybe about 20 minutes. Here's how it goes. Welcome to the forest of logarithms. Uh-oh, Little Red Riding Hood. Log, natural log. Those are natural logs. Starting off, you have a little card sort. It says there are 13 cards, 0 are sorted correctly. When you match up the right ones, you'll know. For instance, x squared to the 5th, well, you multiply the exponents, you get x to the 10th. Those match up. 2 cards are sorted correctly. When you have them all, it'll tell you 13 out of 13. Good luck. Then it gets a little tricky here. Which 2 logarithms in the table add up to log base 2 of 6, which is equal to 2.58? So you could pick more than one answer, but your goal is when you pick 2 of these to add up, you should be able to get 2.58. So look at these, see which ones you could do. There's a couple different ways to do it. Put your answers down here, share it with the class. Which ones add up to 3? A couple different ways to do it, share it with the class. Calculate log base 2 of 10 using the table values. So hopefully, based on the previous 2, you figured out what's going on to find your answer. What is the rule for adding logarithms and so on? There is an extra credit log scramble activity. Have fun. See you next time, guys. Bye.